Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Time complexity, time complexity analysis of iterative program. Iterative program means iterative program means like for loop 1 equal to n if it is going running. While loop means which is not having a function, recursion is not there, just iteration is there. Okay, one by one. Then for that kind of questions we need to find the time complexity of that. Okay, so first problem is a to the power, not a to the power, a is a function, then int I. Now it's running from for I equal to 1 to n, and it is printing, you can say printf Suraj, that's my, or spsyt the code. Now tell me what is going to be the time complexity of that. See, you have to find that how many times that for loop is running, that is going to determine the time complexity, how much time it is going to run. So if this function, if we'll run this function for I equal to 1 to n, it is going to run for n times, so your time complexity is going to be your big O of n. Okay, it's going to be big O of n. Understood? Yeah, correct. Now I will take the next one. The function a, now in between it is having int I j. Now it's for I equal to 1 to n, it's going 1 to n, then again for j equal to 1 to n. Now it's again printing, pf means printf. Okay, the code is spsyt. Okay, now tell me what is going to be the time complexity, how many times the loop is going to run. This is going to, yeah, correct, n square Chandra. This is going to run for n times, this is going to be run for n times. Now for one I it is going to run for n times, now for another I it is going to run for n times, now for another I it is going to be run for n times. So it's like n square. Okay, one n, then again for another one it will run for again I for run, so again for another I it will run for n, another I it will run for n. So it is going to be till n times, so n into n number of times, that is going to be big O of n square. Yeah, correct. Now we will see one gate question. Hope it is clear to everyone. It is gate 1991. Okay, in gate 1991 they have asked. So this is a function int I equal to 1. Now s equal to 1. While, so you please write in your notebook, while s is smaller than equal to n, I plus plus s equal to s plus I, printf the code spsyt. So I change the code, the printf. Okay, I just change the printf. Now tell me what is going to be a time complexity for this. So this means how many times the while loop, this while loop is closed here, and this for this. Okay, this for this one. Now how many times this loop is going to, while loop is going to execute. Now see here, so till the time s value is smaller than equal to n, it is going to execute. When I is equal to 1, when I is equal to 1, I will start with 1. Yeah, s is equal to 1 smaller than n. I am assuming some value n. Okay, you assume some value of n, so it is smaller. Let's assume something, you assume it's smaller, fine. Now again I will become increased to 2. I will become now, I is now, initially it was having 1, then now it become 2. Okay, now it become 2. Okay, inside it, when it went inside, then it become 2. Then is saying a is equal to 1 plus 2. See, it's doing the summation. 1 plus 2, you are going to get here 3. Now s is 3, you print it. Okay, you done the printf. Now again a's value is now 3. 3 is smaller than, yeah, let's assume it's a smaller, let's assume it is some number 20. In assume some number 20. Okay, so now when I s is your 3 is smaller than that, then I is going to become 3. Then it is doing s plus I. S is this, I is this. You are going to get 6. You are going to get 6. Someone has given some answer, n plus 1. Let me see the answer. No, it is not n plus 1. Root n. Chandra is saying root n. Yeah, correct. Chandra is correct. It's root n. Yeah. So now similarly, when I will become 4, then sorry, it will now see now s is 6. 6 is smaller than n20. Yeah, it's smaller. Now I will become 4. Then s plus I, so 6 plus 4, it's going to your 10. That is your s. Now s is smaller than, yeah, correct, smaller than. Then I will become 5. Then 10 plus 5, we will going to get 15. Then again, then 15 is smaller, yeah, correct. Then I will become greater 1. I plus plus is more, will increase by 1, 6. Then 6 plus 15 is your 21. Now it's 21, and 21 is now greater. Now 21 is greater than n, it will go out of the. Okay, now if you see, I is 6. Okay, I is 6. Now add that. See, here we are doing the sum. See, 1, initially it was 1, then 1 plus 2, 3, then 3 plus 3, 6, then 6 plus 4, 10, then 10 plus 5, 15, then 15 plus 6, 21. Okay, so here we are doing the summation of the number. See, 1, then we add 2, then we add 3. Okay, sorry, not we add 1, 2, then we add 3, then we add 4, then we add 5, then we add 6. See, first it was having, the sum was having 1, then we have add 2, then the result we got as 3. With the result I am adding 3. Then we result as 6. Then with the result I am adding, there I am adding. Okay, then I added, see here, 4. Then I added 5. Then I added 6. Now when the sum of the number, these numbers, i's values, will become greater than n, then we are going out of the loop. Then we are getting out of the loop. So it's s is taking the sum of the I. Okay, and I is increasing from 1 means it is taking sum of the natural number. It is taking the sum of the natural number. So when of the sum of the natural number, when the sum of the natural, if see I run here 6 times, so it is taking the sum of the 6. You know the sum of the natural number is n into n plus 1 by 2. So here I executed for 6 times. So when 6 plus 1 by 2, that is your 6 into 7 by 2. So it's 3, see 21. You got 21 only, see 21. So when the sum of the I, that number of times the iteration happened, is greater than n, then it will go out of the loop. Okay, then it will go out of the loop. So let's assume, see, first we have to find that what that program is doing. So it is finding the sum. If you have given some number n, then it's finding the sum of the natural number, and if the sum of the natural number is greater than n, then it will go out of the loop. So let's assume that it is running for n times. So let us assume the loop runs for k times, or I number of times, you can say that k times. So if it is running for k times, then k into k plus 1 by 2, when it will be greater than n, then it will go out of the loop. Then what is going to be the value of k? And I have told you that we are going to find the asymptotic wise, not the exact one, asymptotic wise, not exact value I am finding. It's like k square plus k by 2. Okay, so you can remove the constant like 2 and all these things. So if you see that, if you find the k value in asymptotic wise, it is going to be root n, because it's n square, it is going to be root n. Okay, it's going to be root n, because if you do 2n then minus k, these things will get less. Then you can say that here that its big O is going to be root n. Okay, in terms of n, you can say that the time complexity is going to be big O of n square, because its sum should be greater than the n, and in asymptotic wise it is going to be run k times, so it will be asymptotic wise, I'm not saying exactly times. So in worst case it will go for root n. Am I clear? Because you can remove that constant. K is a constant, 2 is a constant. You can remove that. Now, similarly, now see the next problem. A I equal to 1, 4 I equal to 1, 2. I square is smaller than equal to n, I plus plus. Now, printf the code, that is SPS white, to get 10% discount, that I have printed. Okay. Now tell me what is going to be the time complexity of that program. How much time that loop is going to run. So this I square root that smaller than equal to n, you can even write as I is smaller than equal to root n. You can write now. I will run till the value is smaller than root n. So it's going to run till, for loop is going to run till root n. When I value will become root n or greater than root n, it will go out of that. Yeah, correct, Chandra. If you're done with the writing, then please let me know. Now I will go to the next question. That next one is also a good one. Yeah, fine. Now I'm going to the next one. Next one, you people first try. Please write along with me, okay, so that it will save your time. Please write with me. Now try to find the time complexity of that. Okay. Now see how to find the time complexity of that. You see this loop is always running for 100 times. K equal to 1, k is smaller. It's independent of the value of I and n. It is independent. It's always going to run for 100 times. Always. And see here, this is going to run for n times, and then with the value of I, it depends upon the value of I. When I is equal to 1, it is going to run for 1 times. When I equal to 2, it is going to run for 2 times. When I equal to 3, it is going to run for 3 times. When I equal to 4, it is going to run for 4 times. So this loop is going to be run n times, and it will depend upon the value of I. Okay. So now how to unroll? See, this is the dependency. Here this loop is having a dependency of I. So how to unroll this? Now see how to unroll this kind of questions, how to do this kind of questions. So when I is equal to, Chandra is saying, correct Chandra. So when I is equal to 1, J will run for 1 times, then K will run for, this is inside that, 1 times 100. That is 1 into 100. Okay. Now when I is equal to 2, J will run for 2 times. So this inner loop, that K, I am assuming it is K, it will run for 2 into 100 times, because this loop is going to run for 2 times. For one value of j, it is going to run for 100 times. Then again for another value of j, it will run for 2 again 100 times. So 2 into 2, 2 into 100. Okay. Now similarly, when I is equal to 3, j will going to run for 3 times. 3 times how? 1, 2, 3. See, it is smaller than equal to I. Then each value of j, it will run for 100 times. So k will going to run for 3 into 100 times. So similarly it will go, I will go till n. So when I is n, then j will run for n times, because j is going to start from 1 to this, and k is going to run till n into 100 times. So the inner loop that is running, this one, whatever k, so because the final is the this one, okay, how many times that is getting printed, that is Suraj, that is going to give you the time complexity. So the time complexity will become 100, first 1 into 100, then 2 into 100, then 3 into 100, then 4 into 100, like this. So it will go till n into 100. So you will take 100 as common, then 1 plus 2 here, then 3, then 4 till n times. It is now the sum of the natural number. So sum of the natural number, we know that the formula is n into n plus 1 by 2. So it is going to your, so leading term is going to n square, and constant you can neglect. I have told you that constant you can neglect, so leading term is going to n square, that is going to your 0. Am I clear? Anyone having any doubt? This is also important. Okay, so you please write with me and try to find the time complexity of that. Int I j k n. Okay, for I equal to 1, I is smaller than equal to n, I plus plus, then for j equal to 1, j is smaller than equal to I square, j plus plus, then for k equal to 1, k is smaller than equal to n by 2, k plus plus, and printf, now SPS yt port. This I closed for this. Try to find the time complexity of that. The previous one, it was j was going to till I, but now here it is going to I square. See, here I is going to run for 1 to n, till n times it is going to run. Now depending upon the value of I, this j loop is going to run 1 to I square. When 1, then 1 square 1 time. When I is 2, it is going to run 4 times, because 2 square is 4. When 3, then 4. But it is independent. It is always going to, it is independent. K is smaller than equal to, k is smaller than equal to n by 2. Okay, so it will go from, always it will going to run for n by 2 times. So inner loop is always going to run for n by 2 times. So when I is equal to 1, j is going to run for 1 times, and k is going to run for 1 into square of that, 1 into n by 2 times. When I is your 2, j is going to run for, when I is your 2, j is going to run for 4. So that is 2 square into n by 2 times. This is going to run for 2 square into n by 2 times, because it's always 1 to n by 2. K is always incrementing with 1. Okay, now when I is equal to 3, it's going to execute n times, and it is going to be 3 square n by 2. Similarly, our this I loop is going to run for n times. So when the I value is n, this j loop is going to run for n square times. So then k loop is going to execute for every value of j, it is going to execute n by 2 times. So it's like n square into n by 2. Now if you're done with the writing, then please let me know. I will go to the next slide. Now I will just do the summation of, this is the iteration, this is the times we printed SPS YT, and that many number of times the our function, this iteration, has done. Okay, and whatever summation we are going to get, that is going to be our time complexity. So time complexity is going to your n by 2 into 1 square, 2 square into n by 2, then 3 square into n by 2. Similarly, it will go till n square into n by 2. Now take n by 2 as common, then 1 square plus 2 square. Here you will get 3 square, then you will get 4 square till n square. Now sum of n numbers, natural numbers square, is going to n into n plus 1 into 2n plus 1 by 6. Let me verify it. Yeah, it's correct. So you see the leading term here, n power 1, then 2, then 3, 4. The leading term here is going to get you n to the power 4. That's why it's big O, n to the power 4. Write this. If any loop, depends Kusum, is it clear or not? Please let me know. If any loop depends upon the yeah, if any loop depends upon the value of previous loop, that is the which value? Variable value then we need to unroll this is called as unroll. Whatever we are doing, it is called as unroll the loop as shown in the example. Okay, right? 2n. Okay, this is a constant. See, asymptotic function fn is saying that it's a big O of gn. With the function, with mathematical, I will prove that fn is your this. Okay, is your 2n. Now if we'll take 2n, this function will satisfy when fn is smaller than equal to cgn. Now if we're taking the constant, some constant, it should be greater. Than that. So n I am assuming here, gn I am assuming as n. Okay, I am assuming as n. Now if we're taking some constant whose value is greater than equal to 3, it's always greater. You don't think in that way. You think that it is satisfying that. I am always saying it is asymptotic wise is just the approximation. It is not going to give you the exact time complexity. In GATE, sometimes they will ask you the exact time complexity. Sometimes they will ask you the asymptotic wise. Okay, so it is asymptotic wise. So the question was, A is a function for I equal to 1. I is smaller than equal to, yeah Pratiksha, correct, n, and I is increasing with 2. So printf Suraj. Okay. Now see here, yeah, Rathod, correct. So how we got its time complexity? It increasing by 2. So first I value is 1, means 2 to the power 0. Then 2, increase by 2 is smaller than, yeah fine, 2 to the power 1. Then 2 into 2, 4, 2 to the power 2. Then fourth times, next time it will, then 4 into 2, 8, 2 to the power 3. Then 16, like this way it will go for 2 to the power 4, then 2 to the power 5, till the time it is greater than n. Okay, so now we will assume that it has taken k iteration. So when 2 to the power k is greater than this log n, so that then condition will get false and it will go out of the loop. So I am assuming that 2 to the power k is going to the value of n. After that it will go out of this for loop. Okay, so till this it is going like, so it will wait till 2 to the power k. Okay, when 2 to the power k is equal to n, till that time it is going to execute, because it's saying I is smaller than equal to n. So how many times this for loop is going to execute, you have to find for k. See, first one iteration 2 to the power 0, 2 iteration 2 to the power 1, k, 4 third iteration to the 2. Okay, like this. Assume that when its value was 2 to the k, it's equal to n. Okay, so kth iteration it has taken. Now you need to find the value of k. So k is going to, you can take log on both side. You are going to get log n base 2. So after that, when in kth plus what one iteration, it will go out of this for loop. So total time complexity is going to log n plus 1, but in asymptotic wise you can say that it is going to be log n by 2. Okay, so base 2 is important. So similarly, it means that when I will increase something with 2, it is going to log n base 2. When I will increase with 3, it will log n base 3. Okay, let's take another example. For I equal to 1, so whether you increase the sum value by 2 or decrease by 2, like it was going by 2 now, if you will do I equal to I divided by 2, then also it will be same. Okay, this kind of questions also we will see. So for I equal to 1, I is smaller than I is smaller than n, so you make here smaller, then it will be more correct. So in the previous one also make it smaller only, but for both the cases it is going to be same only. Okay, then I is growing with I into 3, and some work it is doing, that is printing Suraj. Okay, I need to find the time complexity of that. So its time complexity is going to be big of log in base 3. Okay, now it's going to be base 3, so 2 to the, now it will be 3 to the power k when is equal to n. Okay, like same way it will go, I is growing with 3. Okay, you can take an example. Let me show you how it will be. So for this kind of question, just see how the value of I is increasing. So like here, when I is 1 executed, then I will become 3, then 3 square, then 3 to the 3, then 3 to the power 4. Like this it will take, let us assume it is taken kth iteration. So when 3 to the power k is equal to n, then it will go out of this loop. So k will be log n base 3. Okay, yeah, correct everyone, very good. So similarly, I will take one more example. Yeah, anyone having any doubt? If you are having doubt, you can ask me. So this one, time complexity is going to be, since it is increasing with 4, we go of log n base 4. Fine. Yeah, correct, Sweta. Correct, Ami. So as a conclusion, you can write, for this kind of question, so time complexity of this type of loop will be log, right? Time complexity of this type of this types of loop will be log of log of n log of n to base on which, so base is going to be, you can say log, let me write log of n to base on which step it is increasing, on which step it is increasing. Okay, Like if it is increasing with 3, then base 3. If it is increasing 4, then base 4. It is increasing. Okay, that is I indices. You can say how it is increasing. Okay, like 3 4 5, like 3 4 5. Okay, related with this one. So if you're done with the writing, then please let me know. I will go to the next kind of question now. Next question I will go. Are you done with the writing? Is it done? Can I go now? Vibhuti is saying done. Fine. Now see the next one. This is a function. Now try to find the time complexity of that. And today I am having one special class on an academy. So you please come there also. It is also going to be free. So there I am teaching POC. Okay. Try this. Tell me what is going to be the time complexity of that. Tell me the time complexity of this question. Try to find. If you have understood all the concept that I have taught you, then you will able to give me the answer of that. Here all the loop is independent of each other. No dependency. Here it's increasing I plus 1. Here j is from 1, it is running till n by 2. J is increasing with plus 1. Okay, incrementing by 1. Here this loop is not dependent on the value of I. So both are independent. Okay, so this will run for n by 2 times. This will run for n by 2 times because it has started from n by 2 only. So it is going from n by 2, then n by 2 plus 1, n by 2 plus 2, n by plus 2 3. So it is going to execute till n by 2 times, and it is going to execute till n by 2. Okay, from j 1 2 3 like n by 2, and it is going to execute k equal to 1, then 2 3, and it is increasing with step 2. So it is going to be log n base 2. Okay, so since all these four loop are independent, not dependent on the any value of the indices. Okay, so the time complexity is going to be, you need to just multiply the number of times this loop is executed, this loop is executed, this loop. Why? Because when for one value of I, this loop is going to execute n by 2 times. Now for this one value of j, this loop is going to execute for log n base 2 times. See how for loop will execute. When I is equal to n by 2, condition satisfied, then it will go inside. J equal to 1, yeah, condition satisfied. Then for k equal to 1, k is smaller than equal to, till the time k is smaller than equal to 1, it will go executed. Okay, so it will be n by 2 into n by 2 into log n base 2. So it is equivalent to n square log n base 2. Am I clear? Anyone having any doubt? So it is equal to n square log n base 2. Yeah, very good, Vibhuti. So please write as a note for this kind of question what to do. When any loop does not depend, when any loop does not depends upon the other loop, then only we multiply the given loop, then only we multiply the time complexity of each loop with each other as shown in previous example, as shown in our previous example. So it means for this kind of question we are not going to do unroll the loop. Okay, so we are not going to do unroll here. Is it clear? Please let me know. If you're done with the writing, then tell me. Otherwise you can take the screenshot. Please comment if you are done. I will go to the next question then. Take the screenshot. Yeah. Now see next one. And please write with me, okay, so that it will save our time. It will also save you time. 4I equal to n by 2. Now tell me what is going to be the time complexity of that. Now tell me what is going to be the time complexity of that. Execute and see, all these for loop are independent of each other. This is going to execute n by 2 times. It is going to execute log n time base 2 because it is increasing with step 2. This is also executing log n base 2. So time complexity is going to be n by 2 into log n base 2 into log n base 2. So asymptotic wise it's going to n log n base 2 whole square. All are independent. So this is going to execute n by 2 times. This is going to execute log n base 2 because it is increasing with step 2. Okay, we have seen that whenever it increases with step 2, step 3, step 4, then with that step it is going to be the base of log n. Okay, log n base 2, log n base 3, like log n base 4 similarly. Fine. Now see the next one. Now we will see the division one. Okay, so you assume for this kind of question, it's an important question. Assume n greater than equal to 2. N is greater than equal to 2. Okay, so this is the function. Now while n is greater than 1, n is equal to n by 2. You are dividing the n, and now here they are asking the time complexity. As I have already told you that what is going to be the time complexity when you do the multiplication, when you divide. But how to show that? Okay, so it's saying, it's already told you that it's greater than equal to 2. So let's take some number. It's dividing by 2, so assume some number first, that's something in power of 2. Okay, something in power of 2. Now take some number like n equal to, Sweta is saying log n, let me see. So take some number like 2 to the power 1. Okay, when it is 2 to the power 1, yeah, 2 is, it's saying that you can take any number which is greater than equal to 2. So it is 2 to the power 1 greater than 1. Yeah, correct. It's greater than 1. Now it will go inside the loop. It went. Now it divided the n by 2. So it's going to 2 to the power 0, that is 1. Is it greater? No, it is not greater. Fine. Now 2 to the power 2. You take 2 to the power 2. Yeah, greater. Went inside. Then it divided. Then it will become 2 to the power 1. Yeah, it's greater. It went inside. Now similarly take 2 to the power 3. It will go inside, then it will become 2 to the 2, it will go inside, since greater, then it will become 2 to the 1, it will go inside, then it will be 2 to the 0, that is 1, it will not go inside. Okay, similarly it will go. Now see, any number, it's like 2 to the power, yeah, someone has given, okay, yeah, many of you are giving the correct answer. Now if you take some number like similarly, if you are taking n equal to, I am taking now 2 to the power k. Okay, I am taking now 2 to the power k. So it will go inside. Then it will be 2 to the power k minus 1. Then it will be 2 to the power k minus 2. Like this it will go. Now if you take some example, for 2 to the power 2 it is executing 2 times 3. it's executing 3 times. Then 2 to the power 4, when I will take 2 to the power 4, I take 2 to the power 4, then here, then 2 to the power 3, then 2 to the power 2, then 2 to the power 1, then it's 1. So it has executed 4 times. Okay, so if you take the log of that, this log of, I am saying that whatever number we are getting in the power, that many times it is executing. So to the 4 2, you are going to get 4. 2 to the 2 3, 2, you are going to get 3. 2 to the, so if you take the log of that number, that is going to be the number of times it will go inside that loop. Yeah, very good. Very many of you have given the correct answer. So now 2 to the 2, 2, it is going to 2, like 2 to the 1, 2, then 1. Okay. So in this way, for when the power of n is 2 to the power, when n is in power of 2, then you got that it is going to take 2 to the log n. When n is in a power of 2, like 2 to the k, it is going to take log n time. Now if n is not in a power of 2, if now this you will tell me, if n is not in power of 2, now if n is not in power of 2, then what is going to be the time complexity? You tell me first. So there we have seen whatever number we are getting here, that is going to be the number of times it was executing. That's why we have told that it is going to take log of that. So log of, if we will take, we are going to get the that number that is in the power. Now if n is not in the power of 2, what is going to be the time complexity? Abhishek is saying same. Yeah, it's going to be same. Now see, n equal to 20. The only thing it will change in the, it will take either seal, you have to tell that whether it is going to take seal or base, sorry, floor. Okay, this is seal and this is floor. See, seal means if you take 4.1 seal, it is going to be 5. Okay, so it will go to the next bigger number, and if you take 4.1 floor, it is going to be 4 lower number. Okay, so if some number is in decimal one, if you take the floor of that, it's going to take this one. Okay, whatever, like 5.9, floor of that is going to be 5. Okay, and if you take the seal, this is called as seal, this is called as floor. I think floor is, and if you take like 4.9, then also it is going to be 5. It takes the next number, it takes the previous number. Okay, now tell me whether it is going to be log n. Now you have to tell me whether it is going to be floor or seal, whether it is going to be floor or seal. Tell me. Try this, take some number and try to find it. Take n equal to 20 and then try to find it, which is going to be the answer. So whether this or this. So I am taking n equal to 20. Yeah, it's greater, it's went inside, then it divided by 2, 10, then it went inside 5, it went inside, then 2. Okay, it's 2, so it went inside, then 2 to the power 0, it's 1, it will not. So it has executed 4 times. So if you take log 22, you are going to get 4 point something, 4 point something you are going to get. So if you take this seal, that floor, then you are going to get 4. But if you take the seal of that, you are going to get something 5. So which one you should choose? Whether it is going to be log n base to floor or seal. This is floor, this is seal. See, floor, how I remember, I let you know. Floor means the base one, so that it is going to be the lowest one. Seal means the upper one, so it's going to be the bigger one. Okay, this way you can, yeah, correct. So it is going to be floor. So the time complexity is going to be, you write. So the time complexity, you write. So the time complexity is Vigo of floor log n base 2. So when it is in power of 2, no issue. But when it is not in a power of 2, then the issue is there. So it is going to be floor. And one thing you should note, when n is a power of 2, when n is a power of 2, when n is a power of 2, floor of log n base 2 or CIL of log n base 2 is same as log n base 2. It is very important. Okay, it's simple, but sometimes student do the mistake here. If the number is in power of 2, it means you are going to get the exact value 2 to the power k. You are going to get k log of, so you are going to get k. That's why I have taken log, because that many number of times the execution was happening. Okay, so if you take the log, you are always going to get k, because it is a power of. Understood na? Am I clear? So whenever you divide with any number, it is going to be log of n base with which you are dividing, and it is going to be floor. Am I clear? Anyone having any doubt? So if it is clear, then you try this one. Next one. Please write in your notebook. Yeah. Now tell me what is going to be the answer of that. So this one, let us assume 13. Give me the answer of that. What is going to be the time complexity of that? And next one is this. For this, what is going to be the time? Yeah, we say correct. See, it is dividing by 5, so it is going to be log n, log n, log n base 5. Okay, and it is going to be the floor. Correct. Very good. And it is going to be the floor log n base 10. Correct. Very good. So this kind of question, just by seeing the equation, means this loop, you can now give the answer. Okay, means quickly you can give the answer. Now going to the next one. Are you done with the writing? Can I go? Yeah, correct, Patel. And those who are not connected with me till now, you can connect with me in social media account. Okay, in Facebook or in Twitter, in Telegram, LinkedIn. Okay, in WhatsApp also I am there, so that you will get the link of my classes. Okay, fine. Okay, now going to the next one. Now try this. So this kind of question are asked in gate. Okay, this kind of question they ask in gate. Now try this. This is a loop, I equal to 1, I is smaller than equal to n. So it is executing n times, then again one for loop, then again one for loop, j equal to 1, j is smaller than equal to n, j equal to j plus I. See, it's very important. Here I am doing j plus I, not plus 1. With the value of I, it is increasing. Okay, so means here it is dependency with that. Okay, so you have to do unroll. Here unrolling is required. First you try, then I will give this answer. First you people try. What is going to be the answer? Try this. Patel is saying n log n. Okay. Mansu is also saying n log n. Sweta is saying n square. Abhishek is saying n square. Rathore is saying n square. It is n log n. Okay. So Patel and Himanshu is correct. Now see, I have told you that whenever there is a dependency, so here the value of j is increasing based on the value of I from the previous loop. So you have to first do unrolling. You have to first do unrolling. See, I equal, when I is equal to 1, when I is equal to 1, j is going to run how many times? N times. N times. So this SPSYT, the code is going to be executed till n times. Okay, j equal to 1, then 2, because it is going to be increased j plus 1. Now when I is equal to 2, see, when I is equal to 2, it will, j's value will get first 1, then j 1 plus 2, that is 3, then 3 plus 2, 5, then, so it is going to execute n by 2 times, because you are increasing with the step 2. Okay, you are increasing with the step 2, so it will execute n by 2 times, because for half of the numbers it is going to execute. See, 2 is missing. Now for 4, for j equal to 4, it is not going to execute. Then it will, for 7 it will go, because you are increasing with the step 2, it is going to execute, j's value is going to execute n by 2 times. Now when I is equal to 3, it is going to execute similarly 1, then 4. So here it will going to execute n by 3 times, because the number are going to be missing. For I equal to, j equal to 2, 3, 4. So 3 numbers are going to missing. You are not going to execute. Now 4, 3, 7. Okay, then 5, 6. You are not going to execute. Okay, am I clear? Please let me know whether it is clear or not. Please let me know. So for the third number you are executing, so 2 numbers are going to miss here. So n by 3 times you are going to execute for j. This, when I is equal to 3, j is going to execute for n by 3 times. Clear? So similarly, when I is equal to, it will go I is equal to n. So it will go, j will execute till how many times? Whatever is saying, it is going to divide n by n. That is one time. One time. Why? See here, 1 executed. Now it will, j will become 1 plus n, that is n plus 1 is smaller than n? No. Okay, so that many number of times it has executed. Now you have to do the sum, n plus 2, then n plus 3 till 1. Okay, so Akansa is saying, please explain it again. See Akansa, I am saying, see here the dependent j's values, the increment of j is plus I, not 1, not 2. It's depend upon I. Okay, so when I is 1, it is going to increase, like it is same as now j equal to j plus 1. So this loop is going to execute n times, because 1, 2, 3, I will increase with step 1. So it's going to increase n time. Now when I value is 2, it is going to increase 1, then 1 plus 2 is 3, 3 plus 2, 5. So it is, see, one number are going to get missing here. 2 is missing, 3, 4 is missing, 6 is, for j equal to 6, it is not going to execute. Okay, so if you see the number, if you take like n equal to 10, then for 5 values it is going to execute. See, then it will go 9. See, 1, 2, 3, 4, 5. So n by 2, that is 5. So for 5 times, j is 5 times it is going to execute. Similarly, when I is equal to 3, it is going to execute n by 3 times. Okay, because it is now j will increase with step 3. Am I clear? Yeah, good evening Chandra. Akansa, is it clear? So now we are going to do the sum of this. So sum of this is going to give you the time complexity, the number of times the code SPSYT has printed. So that is going to be the exact time complexity. So it is going to be n plus n by 2 plus n by 3 plus n by 4, like this it is going to plus n by n. So you will take n as common, then it will be 1 plus 1 by 2, then 1 by 3, then 1 by 4, then it will go till 1 by n. And this is called as log n. Okay, this is log n. Okay, so it's like n log n. So you can write 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus, like this, it is called as log n, 1 by 1, then 1 by 2, 1 by 3, 1 by 4, it is log n. So time complexity is going to be n log n. Anyone having any doubt? If it is clear, then please let me know. I will go to the next one. Next question is also good. Okay, It is also a good question. So I think that it is clear. You can take the screenshot. Okay. Now going to the next one. Yeah, Amit is saying no doubt. Very good. Now try this. It is a one of the important and difficult. Yeah, it is a little bit difficult and tricky one. Okay. So take some time and try to give me the answer. 2 to the power 2k. N they have given here. Now for I equal to 1, I is smaller than equal to n, I plus plus, then j equal to 2, j they have given 2, while j is smaller than equal to n, j is going to increase with j into j square, and it is going to one do printing. Let us assume spsyt it is printing the code spsyt, done, done. Now try to find the time complexity of that. When k is equal to 0, see one thing here, you see for I equal to 1 it is going to execute till n times. Okay, so it is increasing for with step 1, with step 1 it is increasing, it has went n times. Okay, I1 then 2 then 3 then 4 5 like this, it has increased n times. So take when k is equal to 0. Okay, when k is equal to, there only I try for 1 when k is equal to 0. Okay, when k is equal to 0, then n is going to 2 to the power 20, that is going to be 1, 2 to the 0 is 1, so that is 1, that is 2, n is going to 2. Now see how many times this is going to execute with the value of n. So it is 2, so it is going to execute 2 times. Then j is 2, j is smaller than equal to 2, yeah, it's smaller than equal to 2. Now it's j square, so it went 1 times, it has executed, then it will be j is going to square of that, so it is 2 into 2. Okay, so 2 power 2 is, it is greater, so it will not go, it will go out of that while loop. Okay, it will go out of that while loop. So for 2 times, see n is going to, for I equal to 1 it has executed 1 times, then again I equal to 2 it has executed 2 times. Okay, means next again it will go and it will execute one another times. So for n, like when n equal to 2 it has executed 2 times. Okay, please let me know whether it is clear or not. What I am saying, when I is equal to 1, this thing will get executed, and this is going to execute only one times, only one times. When j equal to 2, then 2 is smaller than equal to n, fine, then j equal to j square is 2 square, fine. So it will go out of whole loop, while loop, done, only once. Then I will become 2, I will become 2, yeah, then it will go inside again, it will get executed. So when k is equal to 0, this j loop, this while loop is executed 2 times. Okay, now take another value, what Chandra is saying. Yeah, now I will take k equal to 2 also, I will take, I will go step by step. Now take k equal to 1, then n is going to, now I will see the code from my notebook, you will also refer your notebook. Okay, then n is going to be 2 to the power 2 1, so it is going to be 2 to the 2, that is going to be 4. Okay, so means the for loop is going to execute 4 times. Okay, the for loop is going to execute 4 times. Now how many times while loop is going to execute? For the value of I equal to 1, then 2, like this. So if you see, first j is going to 2, yeah, done. I am saying, explain again please. Yeah, try to solve by this. See, I have taken k equal to 1. When k is equal to 1, this n is going to n 2 to the power 2 to the power k, here 1. See, so it is 2 to the power 1 is 2, 2 to the 2 is 4. Okay, now see, it is going to execute 4 times. For loop is going to execute, this loop is going to execute n times. So this loop is going to execute n times. Okay, now see, sir, initially is k equal to 0 or 1. Initially it was k equal to 0, Chandra, initially it was k equal to 0. Now see, for when k is equal to 1, 2 to the 2 is 4. Okay, is 4. Now try for j. Now try for j, means this while loop, how many times this will execute it for each value of I. When I is equal to 1, then how many times? When I equal to 2, then how many times? Now when it is 4, that's 2 to the 2, j will go 2. Yeah, 2 is smaller than, j is equal to 2, 2 is smaller than equal to n. Yeah, correct. Then j will be again 2 square, 2 square. Yeah, correct. It will go, sorry, 2 square. It will execute, 2 into 2, 2 square, 2 square, because it is going to multiplication of that, it is going to multiplication of that. Yeah, it's a smaller. Yeah, correct, it's a smaller. It will go, so 2 to the 2 square is smaller than equal to 4. Yeah, correct. Then it will again go, so then it's going to be 2 to the power, means it's going to be 4. 4 into 4, it's 16. So it will not go 16, it j will become, now will become j, 4 into 4, it is going to 16. Okay, so it is going to be 2 to the power 4. So 2 to the power 4 is now not smaller than 2 to the power 2. So when j will become 2 to the power 4, it is not going to go inside the while loop. See here, let me erase that. Here I will show you for k equal to 1, so that it will be easy for me to explain. When k is equal to 1, then it is like 2 to the power 2 to the power 1. Okay, so it is going to be 2 to the 2, that is going to be 4. Okay, it is going to be 4. So now j, so this loop is going to execute 4 times. Now for each value of I, how many times it is going to execute? J is equal to 2. Yeah, executed, it went 2 is smaller than equal to 4. Yeah, correct, it went there. Okay, it went there. Now it did square of that, it did square of that, 2 into 2, so it's 2 square. 2 square is smaller than equal to 4. Yeah, 4 is smaller than equal to, so it went inside. Then j will become 2 to the power 2 whole square, that is 2 to the power 4. Now 2 to the power 4 is smaller than equal to 4. No, no, so it will not go again inside. So how many times now it has executed? 2 times it has executed, while loop executed 2 times, 2 times. Okay, so when k is 1, it has executed 2 times. Okay, when k was 0, it was executed 1 times. This while loop, this while loop, and this is always going to execute n times. Okay, when I, for I equal to 1, this has executed 2 times. For this one, for then I will become 2, then again this loop will get executed, then I will become 3, then again this loop will get executed, like this. Okay, now take k equal to 2. Okay, now take k equal to 2, and you can verify, Chandra, you can verify when k equal to 2. When k equal to 2, now you can verify. Yeah, now when k equal to 2, so n is going to be 2 to the power 2 to the power 2. Now see, it's 2 to the power 4, that is 60. So for that 4 loop, this is going to execute n times, means 16 times it is going to execute. Now for each value of I, how many times this while loop is going to execute? Now for each value, yeah, correct, Chandra, very good. That only I am trying to explain. Very good, Chandra. Now for each value of I, how many times this is going to be get executed? So now see, j equal to 2. Yeah, 2 is smaller than n. Yeah, correct, it has gone inside. Now it will do is square, so it will get 2 square is smaller than. Yeah, correct, so it is 2 to the power 4 only. Then it will get 2 to the power 4. Yeah, it is now smaller than that, it is now smaller than that, so it will go inside. Now it will be 16 into 6, so now it will be 2 to the power 8. So when it is 2 to the power 8, it is smaller than equal to 2 to the power 4. No, then it will not go inside the while loop. So when k is equal to 2, this while loop is going to execute 3 times. 3 times. So when k is equal to 3, while loop is going to execute, sorry, when 2, it's going to execute 3 times. So see here, when 0, then 1 times, when 1, then 2 times, when 2, then 3 times. Then so for k, it is going to be k plus 1 times. So whatever is value I am going to give for k, it is going to execute for k plus 1 times. Okay, so always in this loop is going to be execute n number of times, whatever the value of n, and based on the value of k, for each value of I it is going to execute for k plus 1 times. Then when I is equal to 1, it has executed k plus 1 time. When I is equal to 2, it has executed k plus 1 time. When I is equal to 3, then k plus 1 time. So it is going to execute till n number of times. So total time complexity is going to be your n into k plus 1. Please let me know whether it is clear or not. So now you know that n is equal to 2 to the power 2 to the power k. Now take log on both sides, log n base 2. Again take log here, 2 to the power 2k 2. Okay, yeah, Chandra is saying clear, Amit is also saying with this. So 2 to the power k is going to come. Okay, power will come outside. So it is log 2 base 2, so it is going to 1 only. This will give 1, then 2 to the power k log n base 2. Okay, now you got 2 to the power k is equal to log n base 2. Now again take log both side base 2 log of log n base 2. Now this k will, since it is in power, power term will come outside. Okay, then it will be log of log n. So it is k, therefore k is going to log of log n base 2. Okay, so k is going to your log of log n base 2. So your total time complexity was n into k plus 1. So in place of k you can write log of log n base 2 plus 1. So it is going to be, the leading term is going to your this n log n, n log of log n base 2. So your time complexity is going to your this. So you can give a note, any iterative program, any iterative program, any iterative program can be converted into recursion. So any iterative program we can convert into recursion. Sir, I have one question doubt, can I post it here? Which question, Chandra? Means for time complexity. So any iterative program can be converted into recursion and vice versa. You can convert iterative program into recursion and recursion into iterative program. Okay. Okay, you can send to me in my social media account. Okay. So in next class I will solve your doubt. You send to me personally in LinkedIn or anywhere, in Telegram or in WhatsApp. I will let you know. If a program So we can convert any iterative program into a recursion program and vice versa. Okay. So if a program does not contain either iteration nor recursion, then it will take constant time. That is going to take constant time. Okay, to execute it. So whenever there is no for loop, nothing is there, it is going to take constant time. That is big O of 1. Sometimes they use C. You can even use C to represent constant. Okay, so your time complexity for iterative program is finished. For recursive program, we will see on the next class. Until for it, iterative, if anyone having any doubt, you can ask me personally. In the next class, I will explain that. Okay.